Welcome back, class. Thank you for joining me for our chapter 14 trigonometry unit. Now, you may notice we're kind of jumping midway into trig. So, to prepare you for the ACT, we are kind of abbreviating chapter 14 to give you the essentials of what you need to be successful. Now, the basis of all trigonometry is talking about right triangles, all right? So the first half of this is going to all be about right triangles. And again, by right triangles, I mean a triangle that has a 90-degree angle. Hopefully, a lot of this is going to be review for you from geometry. So hopefully you know the phrase SOHCAHTOA. SOHCAHTOA, what it does is it reminds you when you use a sine, cosine, and tangent, it reminds you what relationship you're talking about. So that SOHCAHTOA means sine is opposite over hypotenuse. The ka means you're talking about cosine, and the cosine is adjacent over hypotenuse. And toa is talking about tangent being opposite over adjacent. Now, when I'm using these words, again, hopefully you remember what that means. So, when I say opposite, I'm talking about the side, if I'm talking about this reference angle, that does not touch the opposite side. All right? Adjacent means touching. So whatever angle you're talking about, it is the side that is touching that angle. Now you may be a little bit confused because, but Mr. Peshman, there's two sides that are always touching that angle. Well, remember that final side is that special side, the hypotenuse. The hypotenuse is always the one that's opposite of the right angle, the longest side. Okay, and again, hopefully that's all review from geometry because I know that you covered at least the very basics of trigonometry last year. But if you ever get confused, if you ever need reminding of what these are, that's what this first little section is for, to very plainly lay out sine, cosine, and tangent. But again, I'm hoping that you remember what those are. So, looking at this triangle right here, we want to label out the sine, cosine, and tangent of that angle theta. Now, the first thing that I'm going to do is I'm going to label those sides so I know what I'm looking for. So I'm going to label that this is the hypotenuse. It is opposite my right angle. That's adjacent. It's touching my angle, meaning this is the opposite side. It is not touching my angle. So if I want the sine of theta, well, sine is so as an opposite over hypotenuse. So sine is opposite, which is S, over hypotenuse, which is T. Cosine, ca. So we're talking about adjacent over hypotenuse. Adjacent is R, the hypotenuse is still T. So the cosine of that theta is R divided by T. Tangent, TOA. We're talking about opposite over adjacent. Opposite is S, adjacent is R. So really, again, all you're doing is dividing side lengths. That's what this boils down to. You're finding the ratio of certain sides. That's what sine, cosine, and tangent are. Now, this one is easy. This one, all you have are the variables to deal with. Now, we can also do this when we're talking about numbers as well. So, for these number ones, well, you may notice something, okay? You may notice we have 3 and 4 here. We have a right angle. However, we don't have that opposite side. We don't have the hypotenuse. So, when you're given two sides and you need the third, remember the relationship for that is going to be Pythagorean theorem. So Pythagorean theorem says a squared plus b squared equals c squared. Well, 9 plus 16 is 25. So that length is 5. Okay, so again, whenever you have a piece and you need to find another one, or whenever you have two sides, you need the third, remember Pythagorean theorem. And now from there, we're talking about those ratios, sine, cosine, and tangent. Again, if we're talking about the theta there, we're talking about adjacent being here, opposite, and hypotenuse. So the sine of that theta, opposite over hypotenuse, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So once you have the sides, it's really easy to do that division. All right, now let's look at this other one. So we have our right angle again right there. So if we need that missing side, let's figure it out. A squared plus B squared equals C squared. So 4 plus 36 gives me 40. So square root of 40 is my C. Now, it's okay that there's a square root there. All right, it happens. So, but keep in mind, again, we know how to simplify that. We don't want to leave it as a square root of 40. We can simplify it. So, I'm going to take that square root of 40, and remember, we can pull it apart. So I'm actually going to call this 2 square roots of 10. Okay, so again, don't forget those basics either. Trigonometry kind of wraps together a lot of things that we cover throughout the year. So make sure you don't forget the little itty bitty details such as that. All right, so sine of theta. Again, here we're talking about our adjacent side, opposite side, and our hypotenuse. So sine of theta, opposite over hypotenuse. All right, now here again, we don't want to forget our basics. We don't want to just leave it sitting like that. So 6 divided by 2, well, that's 3. Remember, you can actually do operations with numbers that are outside the radical or that are both inside the radical. And now remember rationalizing the denominator. Okay, so remember we don't want to leave that square root of 10 down there. So I'm going to multiply top and bottom by the square root of 10. So I get 3 square roots of 10 on top, and then just a 10 on the bottom. Remember, square root times itself just gives you the number that was inside. Cosine of theta. Cosine is adjacent over hypotenuse. And again, we end up with kind of a similar situation. Well, here my 2's cancel, so I just have 1 over square root of 10. But again, we don't want to leave it like that, however. We don't want to leave a radical in the denominator. So let's clean that up a little bit. Remember, multiply top and bottom by the radical you're trying to get rid of. And you end up with square root of 10 over 10 as your final answer. And thankfully, when we get back to tangent, tangent is a little bit easier again. Opposite over adjacent. And we just get 3 for that one. Okay? So again, pretty basic, all right? All you have to do is remember some of those little radical techniques, but aside from that, I believe you should be fine in working on these problems. So, let's continue on to a problem where we're actually solving for a piece of a triangle, shall we? When constructing a telephone pole, there should be support wires attached to the top and nailed to the ground 5 feet from the base. If the wire makes an 80-degree angle with the ground, how tall is the telephone pole? Okay, so I'm going to say, here's my telephone pole right there, and here is my support wire coming down. So the pole we're assuming is just put straight into the ground, making a 90-degree angle. The problem tells us that it's making an 80-degree angle with the ground, and that you want it nailed in 5 feet from the base. And we want to know, how tall does it make that telephone pole? All right, so we want to solve for x. All right, so looking at this, we need to figure out what pieces of the triangle do we have. Well, right now, I'm seeing the opposite side and the adjacent side. So you need to think opposite and adjacent. Which of those trig ratios includes opposite and adjacent, O and A? Hopefully you're thinking TOA from SOHCAHTOA. We're talking about tangent. So this is the opposite side from the angle, the adjacent side from the angle. So the tangent to that angle, which this time we're given is 80 degrees, the tangent of that angle is opposite over adjacent. So I've set up my trig ratio this time. Now, I want to solve for x. So I want you to think, well, right now, x is being divided by 5. So if I want x by itself, I'm going to have to multiply by 5. So 5 times the tangent of 80 degrees is going to give me x. Now, something to know about the ACT. The ACT loves exact answers. The ACT very, very, very seldomly rounds anything or comes up with an approximation for anything. So on the ACT, that is actually what you're going to see for an answer. They're going to leave it in terms of sine, cosine, and tangent because they don't want approximate answers. They want precision. They want exactness. Now, for us, however, we're actually going to do these calculations, all right? So I want you to actually whip out your calculator. Now, the first thing to know is to go into mode and make sure that you're in degrees, because if you're not in degrees, it's going to give you some really wacky answer. All right, so again, when you pull out your calculator, make sure you go into mode and make sure you're in degrees, all right? But once you do that, now all you do is type in 5 tangent 80, and it gives you that x should be about 28.4 feet tall. All right, so word problems. Kind of the gist of that. Draw a picture, decide which one to use, sine, cosine, or tangent, and solve from there. So let's do that with this next one as well. An airplane's angle of descent into the airport is 3 degrees. If the airplane begins its descent at an altitude of 5,000 feet, what is the straight line distance to the airport? All right, so I'm going to say here is my airplane, and I'm not going to draw an airplane. I really, really suck at drawing. So here is our airport down there. All right, so we have this triangle of the altitude of it, which is 5,000 feet. So we have an altitude of 5,000 feet for the airplane. We want to know the straight line distance to the airport. So the airplane just flying straight at the airport. And then it gives us its angle of descent. Angle of descent, that's giving us 3 degrees from the top. Now, the cool thing is though, whenever you find that 3 degrees, if you remember parallel lines with a transversal back from geometry, and again, I'm not going to dive too deeply into that, But if you know that that is 3 degrees, you know that this angle down here is also 3 degrees. So the angle of descent may be giving you an angle you don't want, but in the end, it also gives you an angle that you do want. It gives you that bottom angle in your triangle. So we have the pieces that we need. We have our angle, we have our opposite side, and we have our hypotenuse. So I have my picture. I've labeled what sides I'm given. Now I have to pick out which function I'm going to use, which trig ratio. Well, opposite and the hypotenuse should be pulling you towards SO from SOHCAHTOA, or sine. So sine of that 3 degrees is opposite over hypotenuse. All right, now we want x. Well, the first thing is, just like we did last time, we don't particularly like having a fraction. So to get rid of the fraction, what can we do? Well, I can multiply both sides by that x. So x sine of 3 degrees equals 5,000. All right, however, that didn't solve for my x this time. It just moved it over with that sign. So now, if I still need x by itself, well, right now it's being multiplied by that sine of 3 degrees. So to get it by itself, I need to divide by that sine of 3 degrees. Okay, and that is going to give me my answer. Now, again, on the ACT, that is how they would actually leave their answer because they don't want any rounding. However, we're actually going to finish the problem so we get a realistic answer. So 5,000 divided by sine of 3 degrees, that straight line distance is going to be 95,537 feet approximately. So that plane still has a long ways to go with an angle of descent of only 3 degrees. Okay, but again, goal here, draw me a picture and then figure out which trig ratio to use and solve from there. All right, now something that you should be aware of. So looking at this, there are 3 other trigonometric ratios, things that I don't believe you probably covered in geometry. I have something called secant, cosecant, and cotangent. Now, the tricky thing is, sine pairs with cosecant, cosine pairs with secant, and tangent pairs with cotangent. So you may notice sine and cosine don't exactly go with the ones you expect them to. Now, just an overall thing of what these are called the reciprocals. All right? So notice, cosecant, instead of being opposite over hypotenuse, is hypotenuse over opposite. Secant, instead of being adjacent over hypotenuse, is hypotenuse over adjacent. Tangent, instead of being opposite over adjacent, is adjacent over opposite. So we're talking about just the reciprocal of these ratios, okay, flipping these ratios. Now you may be wondering, how in the world can you remember how to do this? Well, the way that I remember is every pairing needs to have a co to it, all right? So every pairing needs a co. Now what do I mean by that? Well, sine and cosecant, cosine and secant, tangent and cotangent. So, if you can remember that every pairing needs to have a co with it, that will help you remember how to pair it. So the first thing that I do is I always think, of which pairing am I talking about. So if I have a cosecant, I think sine, and then I flip sine, all right? It's easier than trying to remember new rules. Just pair these new rules with sine, cosine, tangent, which you already know. Then just think, oh, okay, I need to flip it upside down. So let's practice that, shall we? So we have another triangle here. Now, we're missing a side. So remember, that means we're going to be using Pythagorean's theorem. A squared plus b squared equals c squared. Well, you type those into the calculator. 25 plus 144 is 169, which gives me 13. So I know I'm going to be dealing with 13 there. And now I have to start piecing my things together. So here we have our opposite side, adjacent side, and hypotenuse. All right, so sine. Sine is so opposite over adjacent. Or sorry, opposite over hypotenuse. Opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And now we're getting into those new ones. And again, this is what I mean about pairing them. So cosecant. Well, remember, if every pairing needs a co in it, that means cosecant is paired with sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant. So remember, every one of them needs a co, so secant must go with cosine. Well, cosine is adjacent over hypotenuse, so that means secant must be hypotenuse over adjacent. Cotangent, again, every one of these needs a co in it, so cotangent must be paired with tangent. So instead of opposite over adjacent, it's going to be adjacent over opposite. And that's how you finish off all of these pairings. All right, so kind of a lot to take in, mainly review, but again, there's some specific new elements here. So please make sure that you write all this down, have all of this in your notes, and then please come back prepared and ready to do your practice work.